Okay, welcome to the another problem on mesh analysis. Here, in this problem, the circuit diagram is as shown. Here it is asked to find the current Ix, or else the current through 2 ohm resistance. Okay, and in this problem, it is you see that another current is there. Ideal practical current source is there. Okay, or independent current source is there. So whenever, see, first you should start with the naming the blocks or loops A, B, C, D, E, F, G, H. Okay, I have given the names to the every node. This is 100 ohm resistance, 100 ohm voltage, 8 ohm resistance, another 4 ohm resistance, 2 ohm resistance, 3, 10 ohm, and 5 ohm. And this is 8 ampere the current. And we need to find the Ix, that is the current through the branch CE. The current through the branch CE. Before that, see, in the mesh analysis, we should not have the current source. The mesh analysis is based on the KVL, that is Kirchhoff voltage law. Okay, another version of the KVL. So, wherever the current source is there, we try to convert that into an voltage source if possible. The current source, which is in parallel with the resistance, this can be converted into an voltage source with a series resistance. Okay, the circuit will be looks like okay, the circuit looks like here. Since this is the direction, this will become the positive and this is negative. See, this voltage is obtained by the current into resistance. What is that current? That is 8 and the resistance is 10. So this is 10 volt, 80 volt. Whatever the voltage here, that will be of 80 volt. And the resistance which was parallel to the current source will now be the series with the voltage source. Will be now with the series with the voltage source. Now applying the mesh concepts, that is considering the current direction in clockwise. Okay, I will make this first as the mesh 1 and I will make this as an I1, this as the I2 and this is as the I3. Now this is the modified circuit. Okay, now applying the KVL, this mesh concept for the mesh. Okay, I can rewrite that the naming of every branch A, B, C, D, E, F and G, H. Okay, we applying the mesh for mesh, that is A, B, C, D, A. We have the equation. See, 8 and 4 belongs to the mesh 1. So 12 I1 as said earlier. If I am dealing with the mesh 1, I1 will be positive and remaining currents will be negative. See, this 4 ohm is shared to the mesh 2. So minus 4 I2 is equal to 100. This is the one equation. This is one equation. And similar with another mesh DCEFD. With another mesh DCEFD, so you have 3 resistances, 4 ohm, 2 ohm, 3 ohm. Whereas this 4 ohm is shared with the mesh 1 and this 3 ohm is shared with the mesh 3. So write that 4 plus 2 is 6, 6 plus 3 is 9. So minus 4I1 4 plus 2 plus 3 6 plus 3 9, that is plus 9I2 plus 9I2 because I am dealing with the mesh 2, and minus 3 minus 3I3. There is, in this second mesh there is no voltage source, so it is equal to 0. As there is no voltage source in this second mesh, it is equal to 0. Okay. Mesh F E G H F, from mesh F E G H F. Okay, this 3 ohm resistance is belong to mesh 2. So, and there's in this mesh, it is no way linked with the mesh 1. Is no way linked with the mesh 1. So, I1 coefficients will be 0. Okay, I can write this as minus 3I2, 3 plus 10, 13, 13 plus 5, 18, plus 18I3, and is equal to minus 10. 18I3 is equal to minus, sorry, it's not minus 10, that is minus 18. Minus 18. So I got the three equations. That is 12I1. See this, when I consider this first mesh will share with the second mesh. So mesh analysis is applied for the planar circuits only. Okay. So for 8 plus 4, 12I1, as in mesh 1, I1 is positive, minus 4I2, and this whatever loop I considered here, moving from negative to positive, so that is 100. Come to the mesh 2. See, mesh 2 is shared with mesh 1 as well as mesh 3. So, for mesh 2 equations, we will have all the three currents equations. So, minus 4 into I1, 4 plus 2 plus 3, 9I2, and minus 3I3. See, I2 is positive because I am in the mesh 2. Similarly, for mesh 3, see, mesh 3 is no way linked with the mesh 1. So, I1 coefficients will not be there. So, that minus 3I2, 3 plus 10, 13, 13 plus 5, 18, plus 18I3, and in my path, I reach first positive. So, it is minus 80. I got the three equations. Okay, three equations. Okay, so already we have discussed so many two problems, both concepts, saying that Cramer's rule as well as the equations. Okay, see that. Okay, press mode until you receive equation. See, equation 1 mat 2 VCT 3. So equation, how many? 3 unknowns. Okay, 3 unknowns. See, this is A1, B1 and C1. What is the value of A1? The value of A1 is 12, B1 is minus 4, and C1, okay, and C1 is 0 because C1 is the coefficient of I3, and D1 is 100. Okay, D1 is 100. Okay, so it is asking for A1. It is asking for A1. The A1 value is 12. Press equal sign. B1 value is minus 4. C1 is not there. That is I3 is not there, so it is 0. D1 is 100. Okay, I finished. Next it asks for the A2, B2, C2, D2. It asks for the A2, B2, C2, D2. A2 is minus 4, B2 is 9, C2 is minus 3 and D2 is 0. Entering that values, A2 is minus 4 equal sign, B2 is 9 equal sign, C2 is minus 3 and D2 is 0. Okay. Now A3, that is minus 3, A3 is minus 3, B3 is 18, A3 is 0, B3 is minus 3 and C3 is 18 and D3 is minus 80. So that substituting, A3 is 0, B3 is minus 3, C3 is 18 and DT is 80. With this I get that X as 9.26, X as 9.26, Y as 2.79 and Z as minus 3.97. Calculate this. In the calculator it shows X is nothing but I1, it shows Y is nothing but I2 and it shows Z, that is nothing but I3. Okay, Z is minus 3.98 ampere. X is 9.26 ampere, Y is 2.79 ampere. This is I1, I2, I3. The answers I1, I2, I3 what we have got. Okay, in this question you ask that in the diagram Ix is nothing but the current I2. See, this is the current I2 is flowing here. Ix is nothing but the current I2 or current into 2 ohm resistance, that is nothing but 2.79 ampere. 2.79 ampere. Okay. This is how we solve. Okay. This is how we solve. Okay.